In this lesson, we look at angles made from an arc on a circle. Given any arc on a circle, we can make or subtend an angle from the endpoints of the arc to a point on the circumference. If we connect the endpoints to a different point on the circumference, we'll form an angle of exactly the same size. No matter which points on the circumference we use, the angles made from the same arc are always equal. This theorem can also be stated as, the angles on the same chord are equal, since the chord shares the same endpoints as the arc. And it can also be stated as, the angles in the same segment are equal, since the chord cuts the circle into a major segment and a minor segment. This angle relationship can be recognized as a butterfly pattern made of two triangles each, with two vertices touching the circumference. Notice that for any pair of angles formed from an arc, there's always another pair of angles on the opposite side of the circle that originate from a different arc. This pair are also equal, though smaller than the opposite pair because the arc is smaller. These vertically opposite angles are also equal. Since these triangles have all the same angles, they are similar triangles. Let's apply this relationship to solve this problem, where we need to find angles x, y, and z. These angles are made from the same arc, so angle x is also 30 degrees. By considering the other arc, we see these angles are also equal, so angle y is 50 degrees. Finally, since we know two angles in the top triangle, we can work out angle z by using the angle sum of a triangle. 180 minus 30 minus 50, giving 100 degrees. And we can summarize our working with the abbreviated reason we used at each step. In this problem, we need to work out this angle, BDC. We're given angle ACB, which is 30 degrees, and angle DAB, which is 105 degrees. We can see these angles are made from the same arc, so angle ADB is also 30 degrees. Looking for another relationship, we can focus on the parallel lines and use this pair of co-interior angles which add to 180 degrees. So, angle ADC is 180 minus 105, or 75 degrees. Finally, we can find the required angle, BDC, using the angle sum at point D, giving 75 minus 30, or 45 degrees. And our working can be summarized like this, with the abbreviated reasons we used at each step.